Question 4. A student investigated the energy change of the reaction between zinc and copper sulfate solution. This is the method used. 1. Measure 25 cm³ of copper sulfate solution into a polystyrene cup. 2. Measure the temperature of the copper sulfate solution. 3. Add 0.2 grams of zinc powder to the copper sulfate solution. 4. Stir the reaction mixture. 5. Record the highest temperature reached. 6. Repeat steps 1 to 5 with different masses of zinc powder. Figure 3 shows the results. Question 4.1. Draw 2 lines of best fit on figure 3. So the emphasis is on 2 lines. The lines should cross. So that's 2 marks for that. So we go on to the curve. You can see we need to draw that line over there. So that's the line there. And we got to draw that line here. And that line should cross. Okay, so the first one is to draw that line. And the next one is to draw that line there. So they will cross there. And 4.2, explain the results shown in figure 3. Do not refer to anomalous points. Use data from figure 3. Okay, so we can see the data we're using here, which is here. We're using those data here. And the first point will be the temperature rises because the reaction is exothermic. That means heat is released until 0.8 grams of zinc is being added. So 0.8 grams is a point here. There you go, that point. And the reaction is just stops. Reaction stopped and finished. Zinc is in excess beyond 0.8 grams. So any more zinc you're adding is not reacting. Copper sulfate is used up. Question 4.3. Explain why using a polystyrene cup gives more accurate result than using a glass beaker. Well, the polystyrene is a better thermal insulator, so that stops excessive heat escaping. There is less energy transfer to the surrounding. So 1 mark for that and 1 mark for that. Question 4.4. Complete the ionic equation for the reaction between zinc and copper sulfate solution. Include state symbol. So we got zinc solid plus copper 2 plus aqueous. That will give zinc 2 plus aqueous plus copper solid. 2 marks, 1 for that and 1 for that. A different student repeats step 1 to 5 for the method 4 times using 0.5 grams of zinc powder. Table 2 shows the results. Here's table 2. So you got the highest temperature reached in degrees Celsius, 37.6, 37.2, 37.8, 37.4. 4.5. Calculate the mean highest temperature reached. Include the uncertainty in your answer. Well, so at this point we need to take the average. So you add them all together, divided by 4 because there are 4 of them, and that gives 37.5 degrees Celsius. In order to calculate the uncertainty will be the range divided by 2. So the range is the highest number, take away the smallest number, and you divide it by 2. So we have the highest number, take away the smallest number, divided by 2, and that gives 0.6 over 2, which is 0.3. And now you can transfer that. That actually meant it's plus or minus 0.3. So we got the values here, 37.5, and then this is the uncertainty here. So we can put in 37.5, the average, and the uncertainty will be plus or minus 0.3 degrees Celsius. Question 4.6. The results show random errors. The student did not make any measuring errors. Suggest one reason for the random errors in this experiment. Starting temperature may be different. Inconsistent stirring, inconsistent use of a lid may cause random errors.